Today we're just going to deal a little bit more with these relatively simple ideas of isosceles and equilateral triangles, but we're going to bump it up just a little bit, just so we can look at a little more complex problem to see what's going on. So here we want to find the value of x and y in the diagram. And essentially I've got two different problems going on here. I need to figure out exactly what's taking place. I do notice I have some angle congruence things, and I want to work with the easiest thing I can first. And what I see right here is I have an equilateral triangle. So that means that y very clearly must equal 4, because it's an equilateral. All three angles are the same, all three sides must also be the same. Second part of the picture I look at, and look at this triangle down here. And the first thing I notice is that it's isosceles, because I have these two congruent angles, right here and right here, which means that this side must be congruent to this side. Now, I know this side is x plus 1, but do I know the length of this side? Well, absolutely I do, because it's an equilateral triangle. That's 4. So x plus 1 equals 4, so x equals 3. I certainly hope you can handle that. You know what? I bet there's somebody out there who's going to go 5. They're going to do 4 plus 1 and get 5. But it's 3. And we've got our solutions. Again, not super complicated, but requiring kind of the next level of concentration as we look at these things when it comes to equilateral and isosceles triangles. Here I've got a picture. We got a lifeguard stand. And we're given that PS is congruent to QR. Okay, so let's know what we've got in our picture. We're given PS is congruent to QR. And we're given angle QPS. So angle QPS is congruent to angle QPR. Okay. First, it says this. Notice I don't have anything isosceles in here just yet, but give me a second. It says, first, explain how to prove that triangle QPS is congruent to triangle PQR. Let's take, where is it? QPS, I'm sorry. Correct that again. Triangle QPS is congruent to triangle PQR. Well, we've already been given that these sides are the same. We've been given that these angles are the same. And the only way I can prove two triangles are congruent at this point is by side angle side. So I've got the corresponding sides. I've got the angles. What do I have to have the side between the angles? I have to have this side right here. PQ in this triangle and QP in that triangle. And can I do that? Sure, because PQ is congruent to QP. It's the same segment, reflexive property. So this is by side angle side. Side angle side then kicks in to prove that those are congruent triangles. Not a full proof, but we're explaining how we know it above the givens. What else did we need to know? We needed to know this fact, and then we had side angle side. So now it asks, explain why PQT therefore must be an isosceles triangle. Well, PQT, now that we look at the picture, PQT, here's the color that shows up here, is this triangle right here. Why does that have to be isosceles? Well, because we just said that those other two triangles, QPS and PQR, are congruent. We know that angle 1 and angle 2 must be congruent because they're corresponding parts of congruent triangles. Okay? Those two angles must be congruent. So angle 1 must be congruent to angle 2 because they're both parts of those congruent triangles, which means that PT must be congruent to QT because of the base angles theorem count. Making that an isosceles triangle. So what it's kind of leading us, what this question is leading us to is it's saying, okay, let's look at a more complex proof now. We didn't do it formally, but we did kind of walk our way through it. First, prove the triangles are congruent, then use that information to take another step. We're going to be doing a lot of that in the second half of the chapter. Find the values of x and y in this diagram. Now, you're probably looking at this going, well, wait a minute. How can I possibly do that? I don't have any numbers in this picture. How can I find the values of x and y? You're right. We don't have any numbers in this picture. None at all. Whatever can we do? But what do we have? We have congruent sides. And we have these three sides are all congruent. So what kind of triangle is that? Oh, that's an equilateral triangle, meaning that x has to equal 60. And this is 60, and this is 60 down here. But wait a minute, I didn't have numbers. I do have this symbol, though, don't I? That's a 90, which means that if I look at this triangle on the left here, which I'm going to enlarge for a moment, just for the sake of ease, looking at it more easily, where this is y, if this angle right here is 60 and the whole thing is 90, that clearly leaves me 30 for that. We also have these sides are congruent, which means this angle must also be 30. So I've used up 60 degrees, leaving me 120 for y. Again, puzzle solving skills. We can't go straight always for the answer. We have to say, what do we know? What information do we get from the picture? What's going on here? How can I use that to find other information? And then we move on. And number 5, we're just going to leave for now. We're not going to worry about that so much. But that's where we're at. Keep working on things. It's going to be a little more challenging day in class tomorrow, just because some of the problems are a little more puzzly than what we did yesterday, but that's okay. We're getting ready for our quiz, and we'll be doing that, I'm sure, day after tomorrow. So.